All right, everybody, so let's try this again. Hopefully you can hear me this time. So we are going to be graphing sine and cosine, okay, and hopefully you did the exploration that was posted on the classroom after you took your test. And so you're kind of familiar with what these graphs look like. You'll see that our graph paper is different. It's still the x and y axis, and it's not really different. I'm sure before you've worked with graphs that had each block would go by 2s, or each block would go by 5s, or 10s, or 100s maybe. Well, in this case, our blocks are going to go by radian values. I chose pi over 4 for each block, and pi over 12 for each little tiny mark here. So if I wanted to say, what's pi over 6? Well, pi over 6 would be 2 of these little things, because 2 pi over 12 would reduce to pi over 6. And 3 of them, you see here, 3 over 12 reduces to pi over 4. 4 over 12 reduces to pi over 3, so that one's pi over 3. Once you get to 6 pi over 12 is pi over 2. And then 12 of these little marks, 12 over 12, would give you 1 pi. So each of these little tiny marks is a 12th. But it's still the same x-axis. So pi, we know this is equal to 3.14. That's where that would be. Okay? We're just not marking them off by 1s like you're used to. So if I wanted to take my unit circle values, all the values that you just learned on your last test, all the quadrantials and everything, and I wanted to graph it, okay, first I'm just going to think about my quadrantial angles. So sine of 0 is 0. Sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is 0. Okay, those points are going to be considered the parent points of your graph. So we've dealt with 7 parent functions already, parent graphs. We did absolute value and x cubed and x squared and all those. That's what we did at the beginning of the year. Well, now we're just adding another parent graph to it. Now, when you connect the dots, okay, if I would use my other unit circle values, they're going to be, some of them are going to be decimals. Like I said, this was pi over 6, and the sine of pi over 6 is a half, so it would be about here. Pi over 4 is square root of 2 over 2. If you plug that into the calculator, it's about 0.7, so it'll be about there. This is pi over 3, and the sine of pi over 3 is square root of 3 over 2, which is about 0.87, so it's going to be about there. So you'll see once you put in all of the values, sine ends up being a nice smooth curve. Now we were already talking about the unit circle values, and this right here we know from 0 to pi over 2, that's quadrant 1. And notice that the values are positive. Now for sine, this would be quadrant 2, and sine is also positive here. Okay, so it's going to be the same 3 values going down this way. So this is going to be 5 pi over 6, 3 pi over 4, 2 pi over 3, but they're all still positive. From pi to 3 pi over 2 is quadrant 3, and you see now sine is negative there. Okay, but the 3 values of the families are still there. This would be 7 pi over 6, 5 pi over 4, and 4 pi over 3. And then the 4th quadrant, sine is still negative, and again those values would still be there. 5 pi over 3, 7 pi over 4, 11 pi over 6. Okay, so that is your whole unit circle value graphed on an xy axis. Now we know that we can add or subtract 2 pi as many times as we want. If I wanted to add 2 pi, this whole thing is just going to repeat. It's going to be the same thing again and again. Same thing with the left. If I subtracted 2 pi, it would be going in this direction. And so these quadrants are just going to repeat themselves over and over again. And in this direction. They're just going to go over and over and over again. So this sine wave goes on forever and ever in both directions. So the domain is all real numbers. It's just going to keep going and going and going. We've talked about this before. You can add or subtract 2 pi as many times as you want. And notice the range. The range is always going to go back and forth between -1 and 1. Okay? So this is your basic parent sine graph. All right? Now, on the ends of our graphs, we are never going to put arrows, because arrows mean that the graph continues on in that same manner. So if I would put an arrow here, that means that the graph continues on in that direction forever. And that does not happen. It's a wave. It goes back and forth. So on all of your graphs for sine and for cosine, we're not going to add arrows on to the end. We're just going to cut it off wherever it is done. Okay? There's two more little terms about the waves that you need to know. The first is the height of the wave. So if I cut this in half, if I look at the x-axis as being like the midline of the wave, you'll see I call them positive waves and negative waves. So this would be a positive and this would be a negative. So above that line and below that line. The heights of those are called the amplitude. And for the parent graph, the amplitude is equal to 1. And notice the positive wave and the negative wave have the same amplitude. That's always going to happen. You're never going to have a wave that has tiny positive waves and then really big negative waves, or vice versa. They're always going to be nice and uniform, so the amplitude will be the same for both. So make sure when you're calculating amplitude, you're not looking from the top of a wave to the bottom of another wave. That's going to be double the amplitude. It's just half the wave, really. Okay, so from the midline. And all waves have amplitude. If you learned about sound waves or light waves in physics or anything like that, they all have amplitude. And the last term is how wide the wave is. How long it takes to go through one positive and one negative wave. So through the whole cycle of all 4 quadrants. However long that takes is called the period. And the period for your parent graph is 2 pi. That's how long it takes to go through one cycle. One positive wave, one negative wave. All the quadrants. Okay, we are going to be looking at changing the period. That's really the only difference that you're going to see between these graphs and all of the parent graphs we did at the beginning of the year. All of the other transformations are the same, but we will be changing the period, and we're going to do that next week. Today we're just going to focus on the basic transformations we did at the beginning of the year. Okay, so there is your sine graph, your parent graph. When we get to cosine, everything I wrote down for sine is the same. The quadrants are the same, the domain and the range are the same, the period, the amplitude, that's all the same. The only thing that's different is where the wave starts. So if you think of your values, cosine of 0 is not 0. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is back up to 1. Now that might look like a V, okay, but it's not. When I copy and paste this, or think of it as adding 2 pi, it's going to continue on in the same manner, and it actually ends up looking almost identical to sine. Now this should make sense that it looks very close to sine. If you look at all the values of sine and cosine from your last test, all the values are the same, they're just for different angles. Sine and cosine are 1 or negative 1 on the axes, and then in the families they're either square root of 2 over 2, square root of 3 over 2, or 1/2. So they're the same values, just moved. So it is just shifted just a little bit. Okay, so if you can just remember which trig function starts at the origin and which one starts at 0, 1, they both end up looking pretty identical. So now let's look at our transformations. Okay, and again, we did this at the beginning of the year with those other 7 parent functions, so hopefully this is just review and you remember it pretty well. If I wanted to shift something up or down, I'm just going to add or subtract a number at the end. So this would look like sine plus 2 or sine minus 2. And I just randomly chose 2. That could be any number. I'm just picking examples here. Now the horizontal shifting left and right, remember it's opposite. So if I'm shifting left, we really want to add, and if I'm shifting right, we really want to subtract. And that number has to be inside parentheses with the x. Remember, it has to be in the function with the x. So this was like inside the absolute value or under the square root. Well, now it has to be in parentheses with the x. And since the x-axis we changed to be radians, I'm going to pick a radian measure here because that's what you're going to see. So the left would be like adding pi over 2, and shifting to the right would be like subtracting pi over 2. A reflection is just putting a negative out front. And this time I'll use cosine, but it's the same for sine and cosine. And then the stretches is when you multiply by a number bigger than 1, and a shrink is when you multiply by a number less than 1. And those work the same way as they did at the beginning of the year. Okay? So all of these are the same. We've just now added sine and cosine as our parent graphs. So let's graph a few. So the first thing you want to do is figure out which trig function you're starting with, and we're starting with sine. So my 5 parent points for sine are these. Okay? Now, this is a shift up. If you're more comfortable with writing it afterwards, you can rewrite this if you want. Sometimes students like that to have it at the end. They don't like it to be at the beginning. But anytime you're adding a number to your trig function, that number is the up or down movement. So all I have to do is take these 5 dots, 5 points, and move them up 4. Okay? Now, before I connect those dots, I'm going to copy and paste them. So we have to continue graphing this the whole wave as much as we can. So it's just going to repeat itself over again. So when I say copy and paste, that's what I mean. You're just mentally copy and pasting those dots so that the pattern continues. And then you can connect the dots by drawing in a curve. Now, I'm not going to grade you on your artistic ability, but you should be trying to round them. Make them curves. Don't make them zigzags like absolute values. So you should try to attempt the curve. Okay? I've drawn thousands of curves because I've done it for 1,000 years. So you don't have to worry if they're not perfect, but you should be giving your best effort to make them nice and round. Okay, so that's what a shift up or down would look like. Now let's look at a stretch. Okay, and this one caused a bit of trouble at the beginning of the year. But cosine, start with your cosine points. Okay, and now the stretch, you multiply your y values. Oh, forgot the L. Okay, so if I take 1 times 2, that's 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. 0 times 2 is 0. And then 1 times 2 is 2. Okay? The mistake that students make is they will move them. So they'll move them up 2 and move this one down 2. You're not moving, you're multiplying. So my 0 points don't change. And that's it. That's the only transformation that's happening. So now, again, I can copy and paste the rest of the curve and draw it all in. Okay. All right. That's how you would do a stretch or a shrink. Shrinks and stretches, they work the same way. Now let's look at a shift. This is the first one that has a shift to the right. So again, start with your parent points, cosine, so this one starts at 1. Now we're going to move to the right pi over 4. Now, I can see that pi over 4 is 1 block. Okay, I have these dotted lines in here to try to help you out a little bit. So we want to move it 1 block. Now, if you're not good with the blocks, because sometimes you won't be able to see what a block is equal, or what your shift is equal to just by blocks, you can always make your denominator 12. If I multiply this by 3 over 3, then my denominator becomes 12. And I know I need to move over 3 little hash marks. So whenever you make your denominator 12, whatever your numerator is, that's how many little tiny hash marks you have to move. I will never give you a denominator that you cannot make into 12. So you'll never see a shift of something like pi over 5 or pi over 20. You'll always be able to make your denominator 12 so that you can use the hash marks. So your graph, those points, will always be on a hash mark. They will never be in between anywhere where you're guesstimating. They will always be on one of those marks. So I'm going to move all these points to the right, however you want to think of it, as 1 block, or you can think of it as 1, 2, 3 little hash marks. Okay, so now it's those purple points. And again, I'm going to copy and paste. Remember, no arrows on the ends. Okay, we're just stopping it where we can't graph anymore. Alright, so we looked at each one individually, up, down, the stretch, and the left and right. So now let's put a few of these together. So this one has three things happening: a reflection, a stretch, and up. So again, the first thing you want to do is draw your parent points. So this is sine, so it's going to start at 0. Now, if you remember, when we first did this at the beginning of the year, you have to do reflections and stretches first. Okay, they're multiplied, so you have to do that first before you can move the up, down, left, right, because those are added. So think of it like order of operations. So I'm going to do the reflection first. So the 0 points will stay put. This one will get flipped down to here, and this one will get flipped up to here. Okay, so now I've done my reflection. Now I'm going to do the stretch. So now I'm going to multiply everything by 3. Again, the 0 points don't move, because 0 times 3 is 0. But this one will go to positive 3, and this one will go to negative 3. Okay. And now the last thing is everything needs moved up 1. So there you have it. There's my graph. Now, this is the first time this says 2 periods. It doesn't just say graph. All the other ones just said graph, and we just extended it as much as we could. Now this says 2 periods, so I only have to copy and paste once, because this is 1 period. It has gone through the whole cycle. So now I'm just going to copy and paste 1 time. And so this is the first period. And that's the second. So 2 periods. I don't need to do anything over here, okay, because all they want is 2. Okay, so there's one at the bottom there. I'd like you to try that one on your own. So pause the video, give that one a shot, see how you do. All right, so there is your graph. Okay, you should start with cosine. So that starts at 1. Now the first thing you want to do is multiply by 1/2, because that's our stretch. So, or our shrink, I'm sorry. So this would go to 1/2, stay at 0, negative 1/2, stay at 0, positive 1/2. So it would be those green dots. Then you're just going to move all of those down 3. And then copy and paste, because they want 2 periods. And you end up with the orange graph. Remember, no arrows on the ends, never arrows. Okay? All right, the next slide, not the next slide, I'm sorry, the next page of your notes has 2 graphs, 2 slides. So again, go ahead and try those 2. Pause the video and give them a shot. Okay, so here's your first one. And notice it only says 1 period, so you didn't even have to copy and paste at all. Okay, so first you should have done a reflection. So you start with your sine parent points. Oops. Okay, and then you're going to reflect. So that just flips that top one and flips that bottom one up. And now you're going to move it left pi over 2 and down 4. So pi over 2 is 2 blocks. I can see here's pi over 2, so that would be 2 blocks. So I'm moving 2 blocks to the left. Or if you made your denominator 12, you would have multiplied by 6 this time. 6 pi over 12. So you're moving left 6 little hash marks. So 1, 2, 3, 4, 5, 4, 5, 6, and then down 1, 2, 3, 4. So all of these points, these green points, you would move left 6 little hash marks and down 4. to get that blue curve that you see there. And again, you only needed one period, no copying and pasting for this one. Now, for the next one, this one was a little bit tricky. Okay, first of all, that pi over 3 is not, you can't put it into blocks. You have to do the hash marks. So this is going to be moved to the right, and it's going to be 4 little hash marks, because I need to make my denominator 12. So I would multiply by 4, which makes it 4 little hash marks over, and then up 2. So you would start with your cosine points. And then the first thing you would do is multiply by 3. And then from those red points, then you're moving everything up 2 and right 4 little hash marks. Now this one does not tell you how many periods, it just says graph. That means you graph the whole thing. Okay, if it does not specify, just graph everything until it doesn't go anymore. Okay, I apologize again for this first video not working out. Hopefully this one, well, if you can hear me, then it did work. There is another page on your notes with 2 more graphs for you to practice. I've put those answers on the classroom so you can check yourself after you try them. And then there's also a homework assignment that gives you 4 more graphs to practice, and the answers are on the classroom as well. On Monday, we are going to look at changing the period. That was the only thing that we didn't talk about yet, and it's new because we didn't have to do that with our old parent functions, but we do have to worry about it with the sine and the cosine graphs. If you have any questions, I will gladly answer them on Monday, or you can rewatch the video or shoot me an email. All right, have a great weekend. Thanks for watching.